October 10th, and it is not 5:30, it is 6:10. Somebody missed the clock. And we this morning have Stewart, who's going to talk about multi-threading, right?
That's correct.
And so here we go. It looks like you got a great outline here. Better let you get going. Sorry about that, everybody. But
all right, well,
there you go.
I was tempted to say good morning, but I realized that our audience is spread across the world. So I've been contemplating the best intro, and given my Tennessee background, I thought howdy would be the most appropriate way to do it. So howdy to everyone. My thanks to Arnold for hosting and posting all of these webinars. This is my first outing, so I feel like it's amateur hour, and hopefully the hook will not come out and jerk me off stage. Anyway, the topic is multi-threading, and I've chosen to take somewhat of an academic approach, which is in contrast, I think, to many of the presentations that have been done here. And I've chosen to take this approach because once you kind of see the outline of what I'm doing, it's really kind of amazingly simple. However, I found for myself the real challenge to dealing with multi-threading is to get my brain correct. And I think that comes from the fact that we are all conditioned to think in a single threading kind of way. If you've been around computing for any length of time, it's only been in the past few years that we've even had multi-core processors. Prior to that, it was a single processor. And most of the applications that I write, and I suspect that people in this group write, are applications that involve a user and a screen and interacting with a screen. Well, by its nature, that tends to be one keyboard, one user doing one thing at a time. And I think that is, at least in my case, in the background in terms of how I think about problems and what I'm accustomed to doing in terms of problems. As everyone knows, the hardware has changed. Now it's not uncommon to have 2, 4, 6, 12, 16. I mean, I'm not sure how many cores they've gotten to in an individual processor. And even with virtualization, a single piece of hardware starts to represent maybe 10, 15, 20 virtual machines. So this concept of multi has really started to pervade computing. Now, we have used timers in the past, and generally a timer was a little thread running out there. And I know in a lot of early presentations I heard about multi-threading, the person would give an example and say, well, I guess you could use it for background printing. And I always felt like that was a really weak response to why you would consider multi-threading. So the one thing I can tell you is I'm not going to talk about background printing. And I think as a model, we can actually look at this presentation to start to kind of develop in our head, what a thread might be and what some of the challenges with threading are. And in this case, I am the presenter, so I could be considered a thread. Arnold is our host. We could consider Arnold a thread. And then each of you are participants, and each of you are threads. Now, if Arnold steps away from the computer right now and has a cup of coffee or makes a telephone call or writes an email, I have no idea whether he's doing that or not doing it. and it really doesn't impact anything that's going on inside of my presenter thread. So the real challenge with multi-threading is not the fact that I'm processing and doing things, and not the fact that you as a participant are sitting there and listening, or not the fact that Arnold is behind the curtain in the control center. The challenge is really, and let's take the microphone as the example, the challenge is communicating between the threads. Right now I have the mic, I'm doing the talking, everybody else is listening, so there's no conflict. But if several of us tried to share the mic and talk simultaneously, then none of us communicate because it all just crashes against each other. So really, that's the big challenge in multi-threading, is how do you coordinate and how do you communicate. So let's turn our attention to WinDev, and they have a command called thread mode. It's a function. Here's the help for thread mode, and what they tell us is we can have it in automatic mode, which is the default, and they will take care of a lot of the things behind the scenes for us, particularly relative to this thread critical section. And a critical section is a piece of code that only one thread can be operating in at a time. And I'm going to, in a minute here, demonstrate why that's important and serves as a way for us to coordinate between threads. And then the other aspect of thread mode is whether it's multiprocessor, i.e. your thread can run on whatever processor happens to be available at the moment, or whether your thread has affinity, which means it is locked to a particular processor. So the default mode that WinDev gives us is that they will automatically manage the critical sections, and our threads can run on whatever processor happens to be available. So this presentation is going to work with those defaults. If you find that you really want to go much deeper into multi-threading, then you should know that this thread mode function is there, and that you have choices that you may want to investigate. All right, I'm dragging a window onto the screen, and what I have here is a number of buttons with some code behind it and a field that has thread count in it. And the thread count function is really pretty simple. You have to be patient with me. I got to get accustomed to moving things around and presenting. Arnold, is the font big enough, or do we need to run the font up a little bit? Hello, am I still connected?
Hey, I had myself on
It's pretty
mute.
small here.
Go ahead and jack it up a little bit, because
All right, I don't know if people are familiar with this.
can you do like control use your mouse wheel to make it bigger?
I can do that.
I don't know if that works in this editor.
Is that adequate?
I
Okay.
I can see it, but
Well, you were the final arbiter.
Go ahead and make it a little bigger then.
A little bigger even?
Yeah.
All right, main menu.
Try control scroll.
Okay.
Yep, good.
All right. This thread is very simple. As you can see, I'm just going to count from 1 to 10,000. I'm going to add a number, and then I'm going to count from 1 to 10,000, and I'm going to subtract a number. And actually, I'm one off here because what I want to demonstrate is this piece of code. And you'll notice here that we're just doing the increment right in the thread itself. And the thread count variable is a member of the class that I'm working on. So I've got two threads, thread count, thread wrong way 1, thread wrong way 2. Both threads are using the same thread count variable that is a member of the class, and they're incrementing and decrementing, and when it's all said and done, the correct answer would be 0. So if I run one thread, then you'll notice that my thread count comes out to be 0. If I run two threads, oh, look at that. I get all kinds of wacky numbers. Okay, that's obviously a huge problem.
The wrong way.
So how do we solve that problem? And actually, what's happening here is something we're very accustomed to dealing with relative to data files, but we are not accustomed to dealing with relative to memory and variables, and that is locking. On a data record, if we knew multiple people are trying to deal with that record simultaneously, then we would do things and unlock the record so that we can keep the activity sorted out and keep it correct. Well, it turns out with multi-threading, we need to do the same thing with our variables that we share between threads. So here's my thread the right way set of functions. And you'll notice what I'm doing is both threads, open this up a little bit, are calling a function called increment thread count. And increment thread count is pretty simple. It just takes that same thread count variable that is a member of the class and adds the increment, which would either be +1 or -1 in this example. The difference in this case is a function is automatically treated as a critical section by WinDev, and a critical section will only allow one thread at a time to process through it, which effectively means that the critical section is locking the variable in this case so that we can keep our incrementing and decrementing accurate. So now if I come over here and I thread count with critical section 1, one thread, I get 0. That's pretty easy. That's what we'd expect. When we run with two threads, then you see we still get 0. So in terms of multi-threading, when we have a shared resource, we need to use a function as a method for accessing that resource, and the WinDev will automatically provide the equivalent of a record lock on that resource so that we can get an accurate answer. Now here's an interesting wrinkle. Nope, that's not it. Sorry, that's not the right piece of code. Here's the piece of code that I want to take a look at. Now in this case, what I'm doing is I'm passing a parameter into a thread. And the normal default for a parameter being passed into a thread by WinDev is that it is passed by reference. However, with threads, WinDev is smart enough to know that if multiple threads are dealing with this parameter and they're passed by reference, then we're going to get into that same problem where our arithmetic no longer equals 0, even though that would be our expectation. So even though it's not seen here, this is effectively a local. So just be aware that when you're passing a parameter into a thread, the thread is going to treat that parameter as a local, and you're not going to see the results of that processing back in the calling routine. All right. Oops. What do I need? Yes. Well, demo doesn't want to, must be still be running. There it is. So all I need to do is get that out of the way. All right, thread count with parameter, one thread. I'm popping up a trace window, and I need to show you a little bit more source code, but we're expecting to get 25 out of that one thread. And then to show that our parameter doesn't change, one thread is doing 25 and the other is doing 50. So let's dig a little deeper here. So, and just to kind of start from the beginning, because sometimes when you jump in the middle, it's hard to tell. The code behind this button says I'm going to instantiate the thread example 1 variable management class. I'm going to get a result thread count, which is coming from test, which I just declared here, running process parameter, and I'm asking for one thread. And here I'm running process parameter and I'm asking for 2 threads to run. So when I go to my class and I look at the process parameter code, then I'm setting up some variables just to keep track of some stuff. I'm launching the first thread and I'm passing the parameter to it, and then I'm launching the second thread and passing the parameter to it. I hang in a loop to give both threads a chance to run, and then when I'm done, I return the thread count parm, and you'll notice that I've got thread count parm set to 0. So then I come down into the first thread and I assign a value of 25, and then I do adding 1,000, subtracting 1,000. I do my little trace, which is the trace window that you were seeing with 25 and 50 in it, and then I'm done. In the second thread, I'm setting it to 50, doing the numbers slightly different, running the trace, and then I'm done. So here's the 0 that's starting everything out, and it stays 0 when the result comes back. And with 2 threads, it stays 0 also. But as you see here, actually down in the thread itself, one of them has got a value of 50, which is what I assigned in that thread, and the other has got a value of 25, which is what I assigned in that thread. So externally, when we made the call, we set the value to 0. In one of the threads, we made it 25, did a bunch of arithmetic on it. It should have come back to an answer of 25. In the other thread, we made the value 50, did a bunch of arithmetic on it, and when it was all said and done, that thread should have come back to 50. And then the results, however, did not propagate back out of the thread to the calling process. The calling process retained the value of 0. So even though you're passing that parameter into the thread, even though you may think that it is a pass by address value, because it's a thread, it automatically knows that it's going to turn that into a local variable. So there's one of the gotchas that you want to just pay attention to. All right. So we'll come back. Another set of code here. Says parameter. As you can tell, I'm outwitted myself here in terms of remembering what I wanted to say on this particular set of code. I believe I'm once again demonstrating how these calling functions work and how the numbers happen. So let's trace back through this code. Just remember, I'll try to leave it up here, but I think it's going to end up behind the screen when I start looking at the code. Maybe, let's see if I can, whoops, that's going the wrong way. Maybe I can do this, and that will help us. Okay, process a parameter, no thread. Alright, so here's the trace. Thread count parm is 0. I'm in the calling routine before. Thread count, no thread, thread count parm, so I'm passing 0 into this thread count no thread, which is right here. So this comes in as 0. I do some arithmetic on it, expecting an answer of 400, and in fact I get 400 and I'm in the function. And then I come back and I say, what's thread count after? And there it is. So what this is demonstrating is here when we pass the parameters, it did not return the numbers that were generated in the thread because we were doing multi-threading. Here, when we passed the parameter, then the return actually got to 400, so that it was not treating it as a local variable. So that was really the purpose of that demo. Okay, and the last little piece of this set of items is reusable code. So far, when I've done a thread and I had multiples, you'll see I have thread method 1, thread method 2. Basically, I am copying code from one to the next. And of course, ideally, when we write code, we prefer to write one set of code and then be able to reuse it. With threading, we can do that, and here's an example of how that can be done. All right, so I'm going to instantiate my object again, calling it test. I'm creating my variable thread count equals 0. And then I'm going to run this thread method start. So thread method start is going to set up a couple of booleans just to keep track of how the threads are doing. And then thread method 1 and thread method 2 will launch the two threads. And then while those two threads are busy, we're just going to wait. And then when we're done, we're going to return thread count. Thread method 1 is now interesting because it is using a class to actually run the code. And you'll notice that thread method 2 is using the same class to run the code. So now we need to take a look at our thread method class and see what's going on there. All right, here's the thread method class. And from each individual thread, we are running this process method, and you'll notice that we're doing exactly the same thing that we were doing in individual methods in the initial demonstrations. We're just taking our thread count and we are incrementing it and decrementing it. So the purpose of this little walkthrough is to show you that if you want to run 3, 4, 5 threads all using the same set of code but processing in parallel, then you can write that core piece of code as a class and then instantiate it in each of the various threads that you're running. If you have a bug in your code, you go back to that base class that you're instantiating, fix it there one place one time, recompile, and then that will propagate into all of your threads. So that gives you code usability using the classes. The thing to pay attention to is this object keyword right here. And you'll notice over here in my method, I'm saying I'm a method process, and I'm declaring it as an object of type thread example variable management. All right, those are the various kind of dry examples, and hopefully there are a couple of things you take away from that. Thing number one is if you have a variable that is shared among the threads, then you want to put the access to that variable in its own separate non-threaded function. And then WinDev will treat that as a critical section and provide the locking mechanism that you need to make sure that when you add and subtract, in my example, and you're expecting an answer of 0, you actually get that answer. Now there's, back to the outline. The second concept that we need to put our multi-threading together is how do we communicate among threads. And WinDev provides an excellent tool for doing that, and it's called queues and their cousins, stacks. Just a brief definition of queue. I suspect everybody knows what that is already. A queue is a variable that when you put something in, and then a second thing in, and a third thing in, and a fourth thing in, it will keep that list. And when you go to extract it from the queue, they will be extracted in the order that they went into the queue. So in a minute here, I'm going to use an example of a ticket window. And of course, people would line up or queue up at the ticket window, and the first person in line should be the first person served, and the second person in line should be the second person served, so on and so forth. So that's a queue. Now the wonderful thing about a queue is it can be virtually any kind of WinDev variable. So I can have a really simple queue that is just a queue of Boolean values or a queue of strings. I can have a more complex queue that is maybe a queue of an arrays, or I can even get more complex and have a queue of classes. And of course those classes might have structures and arrays in them. So you can queue up just about anything that you can imagine of a variable type in WinDev. So that provides a pretty powerful mechanism for shuffling data from one thread to another thread. A stack, in contrast to a queue, is biblical in the sense that the first shall be last and the last shall be first. With a stack, the last item that is placed on it is the first item that is pulled out of it. So at our ticket window, it would be the equivalent of the ticket window serving the last person in line first, and then the next to last person in line next, so on and so forth. So queues are our mechanism for communicating from one thread to another the data that we need to move back and forth. So let's take a look at the ticket booth sample. I think this is it. This is it. And what I need to do is come down here and in that particular program. Okay, just to talk about this for a minute, I've got a ticket booth, and I've got people arriving to stand in line at the booth. And I've written a little routine that just has a random number generator in it that waits a random amount of time and then puts people into the ticket booth. And I have the ability to have either 0 ticket windows open, 1 ticket window open, or 2 ticket windows open to serve the people. And then I have a little message window down here because as we're processing, I want to just notify you and myself of what's going on in our little ticket window world. So if I start this program, there we go. And I'm going to do one other thing here. I want to get the Windows Task Manager up. I believe that is our ticket window. And you'll notice that we've got 10 threads running. So WinDev's already got a lot of threads happening before we even get started. And I'm going to start up my application, and I've launched 2 threads. And you'll notice that I'm pausing 4 seconds, and then I'm putting people in line in 9 seconds and 2 seconds. So that's the random numbers going. You'll notice over here that my thread count has gotten from 10 to 12. And you'll notice here that I'm notifying the screen as people are starting to queue up in line, but since I've got no ticket windows open, then nobody is getting served. So I got a number of people in line, and it's time to open our ticket window. So I open my ticket window. I've got 1 ticket window open. And you'll notice here I've got a message. I'm preparing to open my ticket window, and I got lazy on date and time and just took it in the way it came out. And I'm waiting, and I'm selling 1 ticket to the first person in line, and I'm selling 2 tickets to person number 2. The tickets are incrementing, and you'll notice my threads are now up to 3. But I'm not keeping up with things, and I'm the manager of the ticket window, and I'm got the line is getting longer and longer, so it's time to open up another ticket window. So the next ticket window is opened. This thread count should increment here in just a minute, because this is doesn't recognize it instantly. And you'll notice that I'm now selling tickets from window 2 and from window 1, and this is pretty good because the number of people in line are declining. So as a manager, I'm feeling pretty good. So what we want to do is we will go ahead and start closing the windows down. Our thread count should start coming down. You'll see I'm back to 2 threads because I've closed both of the windows. You'll notice that my thread count over here has come down, and I'm just going to stop the application altogether. And I've got a message up that I'm stopping threads. All the threads have been stopped, and I'm back to 9 threads over here. Okay, the point I really want you to try to appreciate from this is that a number of independent things are going on, and they are communicating with each other. Each ticket window is a thread, and it's just running there independently on its own. The arrival of people in the queue is a thread that's sitting there and running on its own. And then we are communicating all of that with a screen and interacting with it with these start and stop buttons. So there are a number of pieces, a number of moving parts. And to me, this was kind of like the biggest challenge. When you go to write an application like this, you really have to get your mind in a different place. And what I tend to do is to try to think about each activity and deal with it as its own separate entity, and then figure out how those activities are going to communicate with each other. So let's close all that out and take a look at how some of these things are happening and get into the queue as a method for managing our multi-threading. All right, so, well, that's not the best starting point. Let's go to window code. All right, so this is the global declarations for our window. And here I've declared a queue. Queue display is a queue of thread class ticket window dot display. Now that's an interesting syntax, because what I've asked for is to make this a queue of a structure display that I created in this thread class ticket window class. Try to get these things side by side so you can maybe see that a little bit better. All right, so here is this display structure. Display people waiting in the ticket line as an integer, how many ticket windows are open as an integer. People were waiting. At one point I was going to do it as a job application ticket line, so that's why it says job app. How many threads are running, how many tickets have I sold, and my messaging, which was that little window at the bottom that had the information scrolling by. Now I've declared this as a structure in this class, and you have to do that so that this structure will be visible to this class. Well, I really didn't want to have to declare that again as a structure in this window over here. So I kind of by accident stumbled on this little syntax wondering if it would work, and it does work. So I can say, oh, by the way, go to the thread class ticket window class and find the display structure, because that's what I want to use as my queue here in the window. Then I have passing some stuff into the constructor as a method for kind of launching this on the thread. So I'm creating ticket window as my managing class, and I'm passing queue display. Now, queue display is the queue that is a global variable in the main window. So we're going to notify our threads that if you want to talk to my main window, then queue display is where you should send that. And then ticket display is that same kind of thing where I'm grabbing the display from the ticket window. Same as right there. It's just now I've got it here as a local variable in this window. And then ticket message is an array of strings, and that's my messaging. So when I instantiate this ticket window variable and pass the constructor in, the constructor is doing a good bit of work for me. Got to find it here. There we go. So let's get the constructor up. All right, so here comes my queue name, and I'm initializing a bunch of variables to 0 and or blank. And then that queue that I'm passing in, I'm just storing the name of it here as a member of the class. And then that kind of sets things up. And then right down here, I launch a thread for managing the display. Now this thread is not part of the class. It is part of the window. And it is a procedure, a local procedure for the window. All right, there it is. And here's the code that we want to take a look at in terms of using a queue in multi-threading. Okay, this is the kind of the key syntax. While queue display ... addition completed is false, I just want to stay in a loop. So this, once I launch this thread, this while loop is just going to run indefinitely. Then the way to work with queues is you use enqueue to put stuff in and dequeue to take stuff out. So what I want to do here is I'm getting messages that I want to display, so I'm going to be dequeuing from the display. So I'm going to say dequeue my message and wait if empty. So what that does, the wait if empty, will cause this thread to just pause here and not consume any CPU time until a message arrives. When a message arrives, then it will fall through, and I can take the display message that I received and assign it to my local display variable, which I then use to update the screen. So grab the message from the queue, assign it to the local variable, source the screen to pop the information out to the screen. And then this extra little piece of code down here is updating that little window that was at the bottom of the screen with the messages of what was going on. So ticket display is just attached to the various edit boxes as the link, and then source to screen will update those link variables, and then I'm using an array to update that message deal, and I'm causing it to scroll by the way that I add to the array and delete from the array. So list display does the deal. Now there's one more thing to know about queues, and that is we've got this, according to what I said originally, hung in essentially an infinite loop. Well, that's not 100% accurate. It's hung in an indefinite loop until this addition completed property is changed. So the nice thing is if I'm on this DQ line and I'm waiting if empty and the queue remains empty, but the addition completed gets set to true, then this DQ function will go ahead and release, but it will return false. So I won't do any of this processing. I will merely drop down to the end. I will come to here. It will be set to true, and then boom, I drop out the bottom and that thread terminates. So while you've got the queue, addition completed is false. Set up your DQ just to wait for stuff. And I'm over here on the automated procedures. I'm coming down and I'm saying run in background. In this case, I don't need a hyperfile context, so I'm using it without. But if you did need a hyperfile context, then you would go ahead and incorporate that into what you're doing. So execute by calling code one time, run it immediately, and this checkbox says run it as a background thread. If anybody has a question on that, I would be glad to entertain it, because really this is the core of how I implement multi-threading, communicate between the queues. It's really, 1-2 lines of code effectively, and then using the standard little checkboxes that's available to us from WinDev. With this and using functions as critical sections, you get a lot of power that you can go a long way with, and they're really very, very simple to work with. Well, either I've managed to totally confuse everybody, or I've been perfectly clear. I seriously doubt that I've been that.
You're pretty damn clear.
Well, good.
But, anybody, you can turn on your mic and ask Stewart some questions, or throw in some comments, or type in the chat.
Stewart,
Yes.
Yeah,
This is Chris Gordis. So you're using the queue to pass data from the thread into the calling procedure, where they can see it, or you're using it to put it out onto the display directly. But would you communicate between the thread or something calling to a thread with the queue?
Right. What you saw was the display receiving end. What I probably need to show you is the sending end. Let's see if I can. Here we go. This ought to. All right.
Because you started that procedure and it just is sitting out there running.
That is correct. That is the key thing. I just started that
automatically by
thread,
WinDev.
procedure thread, and it's just sitting out there waiting for something to show up in the queue so that it can process.
Okay.
And the way, because of the way WinDev handles those queues, and we're using that wait if empty, when it gets there, it literally doesn't go in a loop in the CPU and eat up your CPU. It just, the thread is just suspended for all practical purposes. Okay, now hopefully this will help get at your question, because now I'm selling tickets at the window. And this is also a thread that's running inside my class. And you'll notice down here, update display, field name, tickets sold, update display, field value, I'm selling a ticket, tickets purchased. So all I'm doing there is calling a function to kind of set up the handling of the information. But the critical thing is right here, if the queue update display addition completed is false, then in queue that update display message. Now, this particular queue is local to the thread because I have a thread that's running that is the managed display thread. And I'm trying to find the critical stuff. Yeah, here we go. This line right here, I'm using indirection to get the name of the queue that is associated with the window and pump the display information out of the class to the queue that is on the window. So that little line of code is right here. Now it is a good idea. Let's go back. One of the gotchas that can get you is right here. If the addition completed is false, then run enqueue. If you don't wrap your enqueue with this little check to make sure that the addition is completed is false, or you don't absolutely for sure know what the status of that is going to be false, then should it be false and you try to do an enqueue, you will get a WinDev error window that is ugly. And I need to wrap this because independent of this thread, to shut down the queue, I will change that to false. So if by chance I've dequeued something on this thread, the other thread that is shutting things down goes ahead between where I dequeue it and when I get down here to stuff it into the display. If it flips this to true, saying that, hey, we're done, shut this queue down, then this will throw up an ugly message to the user. So you want to just kind of one extra step when you're getting ready to put something in a queue that may be closed at any time by another thread, then you want to double check and just make sure that that queue is still available to you.
Now, is that addition completed handled by WinDev? To
Yes.
say that that queue is in,
Well,
like a critical section, or because I don't see you setting that anymore.
yeah, I'm getting ready. You'll notice right here, I have my typical multi-threading class has a start threads method, a stop threads method, and then various methods that are the worker threads, so to speak. So when I get ready to shut down this whole thing and I call stop threads, you'll notice that I run through all of my various queues and I say addition completed equals true. So when that happens, that thread that is monitoring queue people in line in that while loop will now see that that is flipped to true, and it will terminate.
Right.
So you follow that?
Yeah.
And let's see, yeah, start threads. Start threads is pretty simple because all we do is just launch any of the threads that we want to get started. And since we know those threads are looping on those queues, when we get ready to shut them down, we just come down here, flip that to true, and then all those threads just fall through. And you do other things that you need to do in terms of cleaning up. And right here I'm waiting because I want to make sure that things have kind of closed down nicely before I just let it completely fall out of routine. And then so actually I have a base class. It might be worth taking a look at that. Whoops. That's me. Windows open. Here we go. So in my base class, which is just the core of stuff I do multi-threading wise, I have this thread count variable because as I start threads, I like to increment a thread count and keep track of that. So I started out at 0. I have a start thread method which would launch whatever threads that I want to create and do. I have a stop thread method which takes all the queues and says addition completed equals true. And then I have this thread count method that just says if take the thread count and add or subtract according to the value that's getting passed in. And back over here where I'm selling tickets, you'll notice that I do increment thread count 1 before I start the while loop up on the queue. And then when the while loop falls through, I do an increment thread count -1. And since this increment thread count is in its own function call, that thread count variable is being shared among all the threads, but the function call provides the memory locking so that only one thread at a time can get to it, and my math will be correct. And when it says 0, it will truly mean 0 as opposed to being a wacky number because things got out of synchronization.
Yeah, that part I'm familiar with threading and maintaining a critical section on the shared data, and that makes sense. But what got me is your opening and closing the threads and passing the data using the queues.
Yes,
so those queues are maintained per thread, and then you dequeue from one and enqueue into another.
Yes, that's what you would do.
And then each thread has its own manager to say, hey, there's something in our queue.
Yes, and in fact, life gets even better than that. Let's say that, well, the ticket window. gosh, I've got it right here. I didn't even think about that. With the ticket window,
I was going to say if you would walk through that add a person in line call.
okay, let's do that first. How do we get people in line?
You just follow that through.
Okay, so here's my put a person in the ticket line thread.
Yes.
So when I launch the thread, I increment my thread count by 1. That was updating that thread count on the top of the screen that you saw. And then I say, while queue people in line, addition completed is false. That sets up my loop. I'm just doing a random number between 2 and 12 seconds where I just wait so that people arrive at a random pace in the line. And right here, as long as the queue is still available, I update my display with this enqueue to the update display. So in this case, I'm coming out of this put person in ticket line thread and communicating via this queue update display to the manage display thread what I want it to ultimately communicate to the actual screen. And this is actually an interesting piece of code here because it kind of lacks parallelism. I use anyway, the wait statement if it's a non-threaded deal. Well, the equivalent in threading is not thread wait. That means something different. It's thread pause. So got to be a little careful there. If you want to do the equivalent of wait, it's not thread wait, it's thread pause. I increment my person count, and then I check to make sure that the people in line queue is still functioning. If so, I enqueue it, do some more display stuff, and then send out another display message. So we comfortable with what's going on there? I mean, basically it's wait a random amount of time and add a person into the people standing in line queue. So that gets people in the line.
No.
Now I want to sell tickets. And here is another subtle but very useful and powerful thing. Oops, I didn't handle that correctly. I needed to. New window. I want to get 2 windows here.
The difference between, while you're looking, the difference between thread pause and thread wait is the thread wait kills your, well, it stops your thread for a particular event to occur. And thread pause doesn't kill your thread, it just sits there and spins for 6 seconds.
Okay, yeah, thank you for that clarification. And I want to say that waiting is basically the same thing, isn't it, in terms of wait equals thread pause?
Well, if you're waiting for an event, an external event or something to switch, you don't know how long you're going to be.
Right. I guess I use the WinDev command wait like
and not take any clock cycles, I think.
I use the WinDev command wait for, wait 200 just to cause the system to just pause for 2 seconds.
Yeah, that would be the same. It was just sitting there and spinning, checking the timer.
Right. So to me it was kind of interesting. You would have thought thread wait and wait would have been equivalent to each other, but they're not quite equivalent to each other.
Yeah. Or they could have called wait pause.
Yes.
Use the same word.
Yeah. Well, and that's what I was kind of arguing for. Is the left hand and the right hand didn't quite get together on that, in my opinion. Yeah. But even with me, sometimes my left hand and my right hand aren't quite together. Okay, so now I'm selling tickets, and I got sell tickets in window 1, and I'm doing this slightly differently. You'll notice on I got my while loop is done while window 1 is open as true. So I'm using a Boolean variable to manage my while loop as opposed to the queue. I wait a certain amount of time because the ticket person can't just instantly process tickets, and then I do a dequeue pull in line to see if anybody is there, and I wait until somebody shows up. That's on selling tickets window 1. On selling tickets window 2, you'll notice that I'm dequeuing from exactly the same queue.
Mm-hmm.
So I have one
queues
queue.
Are shared between threads.
2 threads are looking at that same queue, and whatever thread happens to be available and whatever thread WinDev decides it wants to assign it to, then that thread will get it and the other threads will not get it. And as far as I know, you could have 3, 4, 5, 6, 7, 8 threads all looking at the same queue, and whoever gets it, and when the next thing comes in, some other thread will pick it up if it's available.
Is the nature of the queue to be in a critical section then? You're not doing anything specific to say, hey, put this in there and protect it from multiple threads grabbing it at the same time.
I think
the fact that it's in a queue makes it thread safe?
Yes, it's you know, as far as I can tell, plundering through the documentation, queues and threads are joined at the hip, and they are intended to work together, and they are thread safe.
Okay. I think that's where I went wrong as you were just going through it quickly.
So, and the real critical point here is now you don't have to do a bunch of management to figure out what thread is available. If you want to have multiple threads like I do here, I want to have multiple ticket windows open. All I have to do is create my queue, and then I can have as many threads looking at that queue as I want, or hopefully more kind of physical example. I got one line of people, and I can open up as many ticket windows, each ticket window being a thread, as I want to. And the queue is doing all the hard work in terms of making sure that whatever thread is available gets it, 2 threads don't get it, and all of that kind of locking and checking and validation is happening for us. Everybody kind of nailed in on that concept?
Chris, thanks for asking your questions.
Any other questions that want to come up? All right. I think that's all the code that is worth kind of taking a look at there. Just so you get a chance to see a little bit here. You'll notice that I declared my class ticket display in the Windows initialization section for this window, and then it has these various members in it, one of which is thread count, and that gets updated via that display queue. And so source to screen and screen to source ultimately results in my thread count number getting taken care of right there. And these guys are the same way. They got various things that they are linked into for source to screen, screen to source. And then this was the array variable so that we could display what's going on there. So really, you know, the bones of multi-threading are queue and addition completed, starting the threads, and then using functions for the critical section for any variables that need to be shared among the threads. So you can either share by running things around in a queue, or you can call a function and then let that function manage the sharing of that variable. Arlen, we can draw a line in the sand here. I have one other thing that somewhat ties into something that I saw in one of the chat groups that takes a look at using threading in services.
Sure, I think more examples make it clearer for people.
All right. Any other questions, you know, out of this section of things before I close this out and try to code?
Chris, you good?
Yeah, I'm good. I have to get back to work though, so I'm gonna beg off. If you could, Stuart, put together a couple of links to the docs that would be pertinent to get in here, keep me from or speed along my search.
Yeah.
Things that were helpful, particularly helpful if you. Is that possible?
I will see what I can do, or tell you what, if you want to email me, LHD Systems, and really anybody else that wants to do it, it's LHD, Larry Henry David Systems, plural, at bellsouth.net.
If you want me to post your presentation outline, and if you wanted to put anything else in there, including your email address, I can post that too, Stuart.
Okay. So yeah, I mean, I'm happy to try to share or make available, you know, anything or you know, answer an offline question should you, you know, have one after thinking about it later. So
I was asked if you would make your demo available for people to study.
yeah, I should be able to make that ticket window demo available. I'll have to kind of carve it out of things and clean it up a little bit, but it shouldn't be. That would be a pretty good thing to actually take a look at, because it incorporates most of the things that you need to do to kind of put something together.
Okay, and I can post that also. So.
Okay.
Very cool.
Great stuff.
All right, so let me close this. Open a project. All right, this is a work in progress. What's different about this is it runs as a Windows service. And there was a question online in terms of how to kind of make multi-threading in a Windows service work together. And I think the thing to do is to start at the very beginning. So here is the project code. And what I'm doing here is I'm creating an SSL or the equivalent of HTTPS kind of socket connection coming into a server. One comment, kind of a left-hand, right-hand kind of comment. The command line function for regular WinDev, command line 1 would be the first variable that you passed. Command line 2 would be the second variable that you passed. so on and so forth. But in a service, command line 1 is the entire command line, not an individual variable. So command line 2 is the first variable that's passed, and command line 3 is the second variable that is passed. So that's just if you've never done a service, that's a tip that may save you some heartburn until you figured it out. Okay, what's interesting about a service, and we'll see this here in just a minute, is they already have a loop for us. So that kind of makes things interesting, because when we were doing our demo, we were putting our thread in a loop. Well, if WinDev already has a loop for us and we put our thread in a loop, then we've got a loop in a loop, and that may not work so well. So we've got to account for the fact that when WinDev is actually running the service, they've already got a loop going. So there's a special little way to do that, and I will show you that here in just a minute. So essentially, we're declaring socket server, this SSL proxy server, that's a class, and I'm creating the variable socket server. And then I'm coming down here, and I am actually creating the socket. And then after I create the socket, I launch my thread. And I'm doing all of that in the initialization section. And what we need to do is get the proxy server code up here. Okay. Here, when we create the class, the constructor is going to get fired. We set up some deals that deal with IP addresses and socket numbers and the name of this particular socket. And then I launch a bunch of threads. Process loopback, SSL socket response, receives SSL socket data, send server, receive server. So those are a bunch of threads that just get started by the very fact that we instantiated the class. And then you'll notice on the destructor side, I'm using the same syntax where I take the queues that I've declared and I'm setting the addition completed equals true, which is going to cause any thread that's paying attention to those queues to terminate. I'm going to time out after 30 seconds, but I'm going to kind of wait for everything to shut down cleanly, which hopefully will occur within my 30-second time frame. Okay, I'm back to the main service, and we're in this loop now. SSL socket wait for connection, called in a loop. They even stick it for you right there. So when we do that, I come over here. Here it is, SSL socket wait for connection. And what I do is I say wait for a socket connection. Oh, by the way, after 2 seconds, timeout. But if we get a socket connection, then I'm going to accept it, and I'm going to enqueue it to my queue receive SSL socket. So that's really, we're in a loop, we wait for a connection, but we put a timeout on that connection so that if we don't get anything, then we will fall through and come back through this loop. I think this is pretty important because as this loop falls through, gives the service a chance to respond to the various windows, start service, stop service, that kind of thing. So you wouldn't want to have a permanent loop for something that you tell it to terminate, because you will interrupt the communications that are built into the Windows service template that WinDev is giving us. So whatever you do in this running service for proxy, you want to make sure it's got some sort of reasonable timeout so that this loop can actually be in a loop, and then the other things that need to happen in terms of a service have the chance to occur.
Hey, Stewart.
So I heard a question potentially.
Yeah, Stewart, this is Arnold. Is that 2020 seconds or 2 seconds?
That is 2 seconds.
Okay.
Yeah, it's a little confusing because sometimes they use hundredths of a second, other times they use thousandths of a second. Okay. I would think that you want to keep this timeout fairly short. I don't think there's, an optimum number. My thought was in picking 2 seconds was if I hit service stop, then within 2 seconds the loop ought to fall through and have a chance to see that stop request and go ahead and deal with it. And that seemed kind of a good balance between giving the service a chance to respond to those external kind of things and not sucking up a lot of CPU by having something in a really just tight loop. So in a lot of ways, I mean, that's really the kind of the answer is if I can wait for that connection, get the connection, and then in-queue the connection into a one queue. This is back to our ticket window thing. I'm going to put that connection into one single queue. Then I can have as many threads as I want hanging on that queue separately outside of this loop thing that are just waiting to pick up that particular request and work with it. So if we wanted to look at the, in this case I've only created one thread, but you'll notice I put a number 1 on it so that if I want additional threads, then I'll just call them 2, 3, 4, and that's why it's a work in progress. But I mean, you'll see the same template that I've had in the other code. When I start this thread up, I increment my thread count. I'm coming over here, and it's execution by calling code one time, run immediately, run as a background thread, and since there's no hyperfile, then I'm making the no hyperfile choice. And here's my queue loop. While addition completed is false, DQ, wait for something to be there, and if something is there, then we process it. And in this case, if there's a ping request, then I turn around and send it through a loopback thing. If not, this particular function is actually proxying it out to another service on another box. And that's just in terms of what I'm doing in this particular case. So if you need to write a service, then you can use all of these same concepts. You just have to be careful that this is not in this kind of loop. Now, if you wanted to use a queue, you could, but what you got to do is add that same timeout. And let's just pretend that that's what was going on, and we were attaching this procedure directly to the running in a loop. Then what would happen here is we say if addition completed is false, timeout. Down here somewhere we would have to put in a break statement. So when we fall through, we actually break out of here and then allow it to come all the way back here, and then this would relaunch it. I mean, that's not a especially great approach, but you could do that. Any questions on that, or did that just make the water murkier than ever?
glazy eyes, I guess.
Well, it can be a lot to absorb.
Yeah, but at least what it did was it saw that you took your example and turned it into your real life stuff. So
yes, I've used it in the socket server kind of approach. I have used it just to, again, to not say, oh, well, you can do background printing, because I think that's a cop-out. I have an application running at a client site, and we have multiple barcode scanners that are scanning barcodes. And these particular scanners don't have any screens, displays, or anything. They literally just scannable and decode it. So we are feeding all of those barcode scanners to one particular barcode scanner server. They are communicating via RS-232. The kind of nice thing is WinDev internally kind of already multi-threads the RS-232. So I thought I was going to have to create a thread per RS-232 port, but they took care of that, so I could use one thread to just communicate with the RS-232 ports and capture the raw data coming from the barcode scanners. And then I have threads, think queues, so that, as each barcode scanner scans, the data that's coming in gets identified as scanner 1, scanner 2, scanner 3, so forth, and sent to that particular queue. So then there's a thread sitting there on that queue waiting to get something from that barcode scanner. And in this case, it's not any one individual scan that's important to me. It's the pattern of scans. So what we're scanning against an order. So our pattern of scans will identify an order number and then start scanning product codes, and it'll say, I'm done with this order. That thread will then launch a message off to another thread that says, hey, would you communicate with the back-end server? And here's this order number, and here's everything that was scanned. Does that agree with what we're supposed to be shipping, or did the person accidentally pick up the wrong item, or maybe we didn't pick up enough items to perfectly satisfy this order? So that message will come back, get dropped back to the thread, and then the person can be notified on the screen of the scanner server, oh, that was good, we're going to print you a packing slip, or nope, you need to try again because you made a mistake on the order. And of course it'll tell you what the mistake is. So there's another real world example where adding another barcode scanner is a matter of just launching another thread to take care of that particular scanner, because all those things are done as little building blocks that communicate with each other, as opposed to a more monolithic kind of application. With that, I think I've said all I know to say, Arnold.
You did good. Thank you for preparing this presentation. I know it takes a lot of work to do these and going through it. But everybody's saying, you got some comments here. Dan says, very cool. Wolfgang says, great stuff. And you know what Chris said. So with that, I think you did your duty. I'm sorry I was late on you, but this is worth the wait.
Well, we're happy to do it.
Thank you, Stewart.
Maybe we'll dream up something else in the future that we can present.
That'd be super.
Yeah. We'll see you at DevCon in a couple weeks.
Yes, looking forward to DevCon, Tim.
Yep.
Alrighty. Thanks again, everybody, for waiting around, and the recording will go up today. And whenever I get any attachments from Stewart, I'll put them up.
So Arnold, I just need to
Okay.
email that to you?
No, just Skype it. Just grab my Skype and just send it via Skype.
Yeah, I don't know that I am plugged into Skype.
Oh, you're not? Email's fine then.
Okay. I will try
Oh,
to
did you
get
not?
that done
I
over the
thought-
weekend, so that if too much time goes by, then it's like everything. It becomes a good intention that never happens.
I hear that.
So we don't want that to happen, because it's I don't think it'll take me too much time to just kind of clean it up and get it to you.
That'd be super. Okay. Thanks so much again, and have a great weekend. Thanks everybody for coming, whoever's still left. Okay. Talk to you all later. I'm stopping the recording.